And the first thing we should talk about in this section is what it means to multiply these radicals. So sometimes you might have a radical, let's say like the square root of 5. And you might be multiplying the square root of 5 times like any number, let's say 4. When you're multiplying these radicals by numbers, you basically can't do anything with this. Square root of 5 times 4, I mean, I guess you could just write it as 4 times square root of 5 like this. But when you're multiplying constant numbers, like plain coefficient numbers, like a plain 4, by any radical, you just multiply the number on the outside. That's all you can do. You don't do anything inside of the radical. However, if you multiplied something like the square root of 5 times the square root of 4, then you actually can multiply the numbers on the inside. So what happens in this case is you would have the square root of 5 times 4 is 20. So when you're multiplying radicals by other radicals, you can actually multiply the numbers on the inside, and then you can simplify further as you normally would. Something else that's important to note is that when we're simplifying radicals, we need to remember the perfect squares, because these radicals in this case, they're all square roots. So in order to simplify square roots, you would need to know the perfect squares. So the perfect squares, you can find them by taking any number like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We could go on forever, but you take any integer number like this and you square them, and all of the answers to all of these squares are considered perfect squares. So 1 is a perfect square, 4 is a perfect square, 9, 16, 25, 36, 49, 64, 81, 100. We could keep going, but these are all your perfect squares. And when you're simplifying radicals, you need all of these perfect squares in order to simplify. So to find products and simplify, we are going to be basically using the distributive property to simplify this expression. So the square root of 3 in parentheses times 2 plus the square root of 5. So in order to simplify this, I would use the distributive property, and I first would multiply the square root of 3 times 2. So the square root of 3 is going to be getting multiplied by 2. And then also the square root of 3 is going to be multiplied by the square root of 5. Everyone writing this down with me? So I'm multiplying the square root of 3 times 2 and the square root of 3 times the square root of 5. Now, 2 different things happen in this problem. On the left-hand side of the plus sign, the square root of 3 times 2, you can't do anything with that because 2 is not also in a square root symbol. So this would just be 2 times the square root of 3 like that. However, the square root of 3 times the square root of 5, you can actually multiply the 3 and the 5 together because they're both inside square root symbols. And you can rewrite that as the square root of 15. When you go to simplify radical expressions, the last thing that you do after you multiply is figure out if any of the numbers on the inside of the symbol, they're called the radicands, these numbers here. If any of these numbers have factors that are perfect squares, like the perfect squares up here, then you need to simplify it by rewriting that number as a product of the perfect square and what other factor it has. And then you can simplify further. But 3 only has 2 factors, 1 and 3, and 15 only has 4 factors, 1, 15, 3, and 5. None of those numbers are perfect squares that will help simplify. Like 1 actually is a perfect square, but it won't simplify it. So the answer would just be 2 square root of 3 plus the square root of 15. That would be the final answer for this one. There's nothing else you can do with that. But sometimes you can simplify further. Let's see if we can in letter B. So the first thing we're going to do is multiply the square root of 2 times 4. And then the second thing we're going to do is multiply the square root of 2 times the square root of 8. And we're going to hold this together with a minus sign. So when I go to simplify this, the first left part of it, the square root of 2 times 4, you cannot multiply the 4 times the square root of 2 like on the inside. So really it's just going to be rewritten like this, 4 times the square root of 2 like that. But on the right-hand side, you can multiply the 2 and the 8 and rewrite this as minus the square root of 16. I can do this because the square root of 2 and the square root of 8 are both in the symbol. Yes. Yeah, so now we can simplify further. So because the square root of 16 actually is a perfect square, since 16 is a perfect square and it equals an integer, I can simplify this down to be the square root of, 4 times the square root of 2 minus just 4, because the square root of 16 equals 4. I'm looking at the radicand inside of the symbol and it's a 2. There's no perfect square that goes into 2 that will make it become more simple. And there's nothing I can do with the minus 4 because they're not like terms. So this would be the final answer. 4 times the square root of 2 minus 4. Okay, and then one more left to go. So letter C, we're going to use the distributive property and we're going to multiply the square root of 6 times the square root of 12 first. So when I do that, I can multiply the 6 and the 12 in this case because they're both in the symbols. And then I'm also going to multiply the square root of 6 times the square root of 3. And I'm going to hold this together with a minus sign. So when I go to multiply the square root of 6 times the square root of 12, I can multiply 6 times 12 because they both are inside the symbol. So this turns into the square root of 72 minus, I can also multiply the 6 times 3. And this will be minus the square root of 18. Now we're going to try and simplify this as much as we can. In order to simplify radicals, you look up here at the perfect squares. You want to rewrite 72 and 18 both as products of perfect squares and whatever other number that would multiply to be it. So what we're doing is thinking about the factors of 72. And you don't have to list all of the factors. Basically, go down the line. Is 4 a factor of 72? Is 9 a factor? Is 16 a factor? Is 25 a factor? And you're wanting to try and find the largest perfect square factor that goes into 72. As soon as I saw 72, the first number that came to my mind was 9. But actually, there is a bigger perfect square that's a factor of 72. And you want to choose the biggest one. What's the biggest perfect square that's a factor of 72? "12 is not on here on this list. So we're looking at these numbers here. Does that make sense? Yes, 36. 36 times 2 is 72. So what I'm going to do is rewrite 72 as 36 times 2. And I'm specifically choosing 36 because 36 is the largest perfect square that goes into 72. Similarly, I can do the same type of thing with the 18. I'm going to split the 18 up as a factor, as the pair of factors with one of them being a perfect square. So what would I split 18 into? Lucy? Yes. I'm going to split it up into 9 times 2 because 9 is a perfect square. So here's what happens. Anything that is a perfect square, you can take the square root of it and bring that answer out on the outside. The square root of 36 is equal to 6. So on the outside of the square root symbol, I'm going to write a 6 because the square root of 36 does equal 6. And what I'm left with on the inside is the square root of 2. Minus. Similar to that, I can take the square root of 9 out of this one. The square root of 9 is 3. So this turns into a 3 on the outside, and then what's left on the inside is the square root of 2. Because these are like terms, this is 6 square root of 2's minus 3 square root of 2's. Because they have the same exact radical with the same exact radicand, I can actually subtract 6 minus 3, and I can get 3 square root of 2 as my final answer. Yes?
Why can't we cancel out the...
So they don't necessarily like cancel out. They're almost similar to like variables. Like if this said like 6x minus 3x,
Okay.
then you would basically just subtract the 6 minus the 3 and get 3 x's as the remainder. Good question. All right, great. So that's how we simplify radicals after we multiply. So sometimes we have to use the method FOIL to multiply. So in these examples here, we have to use this foiling method. If you remember, FOIL stands for first, outer, inner, last. And it's just an acronym to help us remember that when we're multiplying two terms by two terms, every term in the first needs to be multiplied by every term in the second. So there's going to be 4 things we have to do when we go to multiply these examples below. So we're going to take 2 square root of 7 minus 4 and multiply it by the square root of 7 plus 1. So first, you would multiply 2 square root of 7 times the square root of 7. So I'm going to write it out just like that, 2 square root of 7 times the square root of 7. And then the outer numbers would be the 2 square root of 7 times 1. So because it's a positive answer, because everything's positive, I will put a plus sign. And 2 square root of 7 times 1 is just 2 square root of 7. So I'm not going to even show the 1. And then next is the inner numbers. That's negative 4 times the square root of 7. The answer is going to be negative. So I'm going to put a minus sign to hold them together. And I would write this as 4 square root of 7 like that. And then last would be the negative 4 and the 1. Negative 4 times 1 is negative 4. So I would just put minus 4 at the end. So I have 4 different terms here. And now it's time for me to multiply and simplify. So let's start at the very beginning. 2 times the square root of 7 times the square root of 7. Because these are both in radical form, I can multiply the 7 and the 7 and get 49. So this will be 2 times the square root of 49 here. And the square root of 49 actually equals what? 7. So this is really going to turn into 2 times 7. I'm going to run out of room. And 2 times 7 is just equal to 14. So that left part, that first thing all together, it ends up just equaling a plain 14. So I'm going to rewrite the work over here so I have more room. So basically it says 14 plus 2 square root of 7 minus 4 square root of 7 minus 4. Okay, moving down the line, let's try and simplify 2 square root of 7 minus 4 square root of 7. I can combine these like terms because they have the same exact radical. So 2 square root of 7 minus 4 square root of 7 would be a negative 2 square root of 7. Similarly, I can also combine this 14 with this minus 4 because these are plain numbers. 14 minus 4 is 10. So your answer can be written as 10 minus 2 square root of 7. Or you can write your answer as negative 2 square root of 7 plus 10. So when you're using foiling, you are just doing the first, the outer, inner, last to multiply, and then you would simplify. So I want you guys to try letter B. Same type of process, but now we have just some variables instead. So take a few minutes, try B, and then we'll go over the answer. All right, so when we're solving this problem, the first thing we're going to multiply are these first numbers here, the 3 and the 1. 3 times 1 is 3. Then we're going to multiply 3 times the square root of x. And because that's a positive, I'll put plus 3 times the square root of x would just look like this, 3 times the square root of x. And then the inner would be a negative square root of x times 1. A negative square root of x times 1 is just minus square root of x. And then the last would be negative square root of x times a positive square root of x. So I'll show that out. That would be minus the square root of x times another square root of x. All right, so simplifying that. I have a plain 3 at the front, and then here I have 3 square root of x minus 1 square root of x. I can combine these together to be 2 square root of x. And then right here, this minus square root of x times x, I could technically multiply the x times x and get x squared. And when you take the square root of something that's a perfect square, which x squared is a perfect square, basically the square and the square root cancel. So this would end up equaling 3 plus 2 square root of x minus just a plain x. And that would be the final answer. There's nothing else you could do with that because we don't have like terms. 3 is a constant number. The 2 square root of x is already simplified from combining the 3 square root of x minus 1 square root of x. And then minus x at the end can't combine with the square root of x because they're different. The one's in a radical form and one's not. So that is all of the notes for today. Yeah.